Um, there were. I want to make sure we're actually recording here. Okay. So I want to go over a couple quick things. Oh shoot, I left it upstairs. On the homework that I just gave back, because there were a couple mistakes I saw over and over again. Does someone have? Okay.
Do you want the sheet?
Yeah, someone who. So I get the question numbers right. Yeah,
Here.
someone.
Yeah, you got some mix.
Okay. Um, so the so for question 2, right? So we're given the matrix. Minus 1, 2, 0, 3, 0, minus 1. Okay. I say write these out in matrix notation, right? So that's A, right? That's the same as Aij in inducer notation. Right, so A, I, everyone basically got that this was the trace of A and got the number. The next two, a lot of people, some people missed that, right? So this is A, I, J, A, I, J again. Right? Some people somehow missed that you were summing over both I and J here. They're repeated indices, right? So this is there's no free indices, right? So this is just one expression, and so this is just A11, A11 plus A12, A12, A13, A13, all the way through, all the way, across all 9 terms. The next one, Aij, Aj, I. A lot of people made the mistake of basically saying this was exactly the same as the first term, but the indices are switched. So this is it's still one long expression, but it's just A11, A11 plus A12, A21. Right? It's the inner product of A and the transpose. So in matrix notation, this first one would be A double dotted A. This would be A double dotted A transpose. And then a lot of people, Aij, Ajk, did the opposite mistake and gave me a scalar expression for this. But I and K are both free indices. Right? So
the first one will be A transpose.
The first one?
Yeah.
It's Aij, Aij.
Because A12 is multiplying with A12.
Yeah.
So A12, if it is in row, the other one should be in column. A12, A12.
Oh no, but this is the dot inner product, right? This is the dot product. So the double dots mean it's the same as element-wise multiplication of the two matrices, right? Because you're always doing this exact same operation. This is just matrix multiplication. This is A times A, right? So if you wrote out all the equations but didn't put it into the matrix notation, I took a very small amount off, right? So that was an error. Question 3, part. Everyone basically got A and B correct. Some people wrote it out a lot more, but what I want to get across is, so delta ij, right? Basically, everyone got that this is 3. The next one, delta ij, delta jk, delta ik equals 3. Right? A lot of people didn't use the substitution. I wrote this wrong. Delta ik. Right? The substitution property for the delta. Right? So you could have just written this as delta ij. Substitute I for k. Right? That gives you delta ji. Right? And of course, for the delta function, it doesn't matter what order the indices are in. Right? So this is equal to delta ij, delta ij. And of course, that's what you had up here. So that's 3. Right? So you could have saved a lot of time not written out every single, the complete summation. And then the same thing with the third. Delta ij, delta ij. I must have written this solution out on half the homework assignments. But basically, you could go through the same substitution procedure. Right? Delta ik, delta I m is delta km, right? And then you can do the same thing here with I and m. So that gives you delta mk equals delta km, delta km equals delta km, right? And that's much, much faster than writing out all of the expressions, right? And that was kind of the main purpose of that question, is just to get you used to manipulating things with the delta. A really minor thing on question 5, right, when I was writing the following sets out in condensed form. A lot of people they wrote out the terms of the matrix and then wrote delta ijp, but that's not an equation by itself, right? So, right, to make it an equation, you kind of need the equal sign and something on the other side. So that again was a really tiny deduction. I'm not trying to hit people on the homework. Another big issue was on question 6, the finding the transformation matrices. Basically, everyone got A and B no problem. Right? There was 1 or 2 issues where people got the orders of the columns or something mixed up when they drew it out, but that wasn't. Part C, on the other hand, we're doing a rotation about x1, so we'll call that q1, followed by q2, right? So a lot of people got the order of the multiplication wrong, right? So if B is a vector that we're rotating, right? First I do q1 times B, right? That's the rotation about a 90-degree rotation, right? And that gives me some other vector, that gives me some vector B prime, right? If I want to act on B prime, I would do q2 B prime, right? Which means I need to put the q2 out here, right? So a lot of people did right multiplication, right? We read from left to right, so they put q1, q2, but it needs to be q2, q1, right? So we left multiplication for composition. I didn't, 8 and 9 were no problem whatsoever. I didn't grade points wise for 7 and 10. I basically, if you attempted them, I gave everyone full credit. Because in the recording, so I'm going to rewrite that out real fast. Epsilon I j k equals epsilon. So as long as I keep things in order, right? So here's I j k, so I can go j k, wrap around back to I. Right, and then I could do k I j. I'm keeping them, right? If I write them in this triangle I j k, as long as I go around this triangle in the clockwise way, my sign. If I go the other way around, it becomes negative. Okay, so which means I have 6 and 6, so I have 36 possible, right? If I'm multiplying the two of them together, right? Basically, this first term is 1 when both of these are even permutations or both of them are odd. And the second term, both of those go to 0. And this first term goes to 0 when they're mixed. One's even and one's an odd permutation. Right? And if you think about those 3 distinct possibilities, right? It's really easy to show that if they're both even permutations, then it's always equal. It's equal to this. If they're both odd, it's also equal to this. And if one's even and one's odd, right? So that's another way of proving it. I think that's a little more intuitive than the determinant thing, and a little less time consuming than writing out all the terms. 10, most people who, there were either you cued in as to what I was asking for, or you asked enough questions, right? You came and asked me what I was asking for. And you got it in a really trivial way, or you didn't, and you wrote a lot of stuff out. So,
What was problem number 10 again?
problem is 10 is where I ask you that if I have Bij is a second-rank tensor, Ai is a vector, show that their product Cj is also a first-rank tensor, right? And so a lot of people showed that the product of a matrix and a vector is also a vector, right? But that doesn't show that that vector is a tensor, right? So to prove that it's a tensor, you have to show that it possesses the appropriate coordinate transformation behavior, right? So we know that if vector C is a tensor, then QC should be C prime, right? And also that if I'm just doing a change in coordinate frame, I should know that B prime should be QB Q transpose, and A prime should be QA, and that it shouldn't matter whether I do the multiplication first and then transform, right? Or if I transform A and transform B to the new coordinate frame and then multiply them together, right? I should get the same answer, right? So what I need to show is that Q, right? So I need to show that B prime A prime equals C prime, which is also equal to QC. Right? And if I just plug this in, right, QB, Q transpose, QA is C prime, right? Q transpose is equal to Q inverse, so QB, Q inverse, QA, right? Q inverse times Q is identity, right? B times identity is just B, so that gives me QBA equals C prime. B times A is equal to C, so QC equals C prime, right? Which is the end, right? QE. Right. So basically, the whole idea there is just to demonstrate that if something's a tensor, right, it doesn't matter what order we do the coordinate transformation in, right? We can, as long as we're consistent about when we're applying the transformation, right? It doesn't matter if we do all the operations in one frame and then transform it to another frame, or transform everything first and then do the operations in a new frame. Right? So I'm going to.
So it's basically taking the dot product.